My name is Michael Rufo, and today we are going to be talking about atoms, what make up atoms, elements, and how we can use differences in element properties to learn what was inside your water samples. The water samples that you brought in for the experiment looked clear as if there was nothing but water and maybe some dirt in them. After a few tests, however, we saw that there were other elements floating around in the water that we had to use chemistry to see. One of the elements we looked for in the water samples was iron. In large quantities, iron is a shiny heavy metal that looks like silver, shown here. If we zoom in on iron, we can see that it is made up of building blocks called atoms. These atoms form organized lines that stick together and form solid iron. If we zoom in again on the iron atoms, we can see that they too are made up of even smaller building blocks called subatomic particles. These subatomic particles are called protons, which have a positive charge, neutrons, which have no charge, and electrons, which have a negative charge. In the iron atom, there are 26 protons, 30 neutrons, and 26 electrons. The protons and neutrons can be found in the bulky sphere-like center of the atom called the nucleus, while the electrons move around the nucleus in what is called the electron cloud. Iron and its 26 protons is not the only element found naturally. In fact, scientists have identified and organized 118 known elements, 92 of which can be found naturally on Earth, into the periodic table. These 118 elements are identified based on the number of protons they have in their nucleus. For each proton, atoms will also have an equal number of electrons, and it is the protons and electrons specifically that give each element its own unique characteristics. Looking back on our iron atoms again, we can zoom in on the electron cloud and see electron energy levels that are at different distances from the nucleus. Electrons that are found in energy levels farther away from the nucleus have more energy than electrons found in energy levels closer to the nucleus. Electrons are more comfortable when they have as little energy as possible, so they will usually be found in the lowest energy level as it can be, unless energy is added to the atom. The energy difference between each energy level for electrons is actually a specific number affected by the protons in the nucleus, or depending on the element. This means that the energy difference for an electron in an iron atom is different than the energy difference for an electron in a copper atom. If we add this specific amount of energy to the atom, then the electron will jump up to a higher energy state. This specific amount of energy can be translated into light, and since the amount of energy in a light is related to its wavelength, we can choose the amount of energy we add to the atom. Light will appear as different colors to us depending on the energy or wavelength of the beam. This light with specific wavelength is useful to us because it allows us to selectively excite only certain elements in the water sample. Because electrons like to have as little energy as possible, the excited electrons will eventually relax down to their ground state in a process called emission. When the electron drops back down to the lower energy level, it will release the energy it absorbed in the form of light called emission. Emission is useful because during our tests, if we see that light at the wavelength that excited iron electrons emit when relaxing, then we know that iron is present in our sample. Further, we can determine how much of the element is in the sample if we measure the wavelength of light that is emitted from the atom when the electron relaxes to see how bright the specific wavelength of light is. The brighter the light means the more of that element is found in the water sample. This is similar to the phenomenon of turning on light bulbs in a dark room. If you do not turn on any light bulbs, then you will not be able to see anything. If you turn on one light bulb, then light will fill the room and it will be easier to see. If you turn on a second light bulb, the room is filled with even more light and is brighter than when using only one light. The same thing happens in a water sample in that the more atoms of the specific element in the water, the brighter the light will be that is emitted.